Hello. Today we solve the question from SSSCE Core Mathematics 1993 Objective Question 40. And this is what we have here. It says that U is a set that contains triangles. U is a set of triangles. And set S equals isosceles triangles. Set Q equals equilateral triangles, and set R equals right angle triangles. So before we go on, let us try to understand what these things mean here. Before we start, if today is your first time on my students class channel, don't forget to subscribe and click the notification button so that you'll be promptly informed anytime we upload a new video. And hey, one more thing, click the like button so that the video can reach a lot of people. Thank you. Now let's continue. Of course, we are dealing with sets because we see the set builder notation here. And first we see a triangle, so we are told that U is a set of triangles. So triangles. A triangle is a plane figure that has got 3 sides and 3 angles. So there is an example of a triangle. There is a triangle, or there is also a triangle, because it has got 3 sides. Let me show those sides with different colors. There's one side, and of course we can have another side going that way. Oh, I said I'll use different colors, so let me use this color. So another side this way, and of course you have a third side, and these have got angles. There is the first angle, and there is another angle, and there is also another angle. So you can see equally we have 3 angles here. So a triangle is just a plane figure that has got 3 sides and 3 angles. So the universal set is a set of triangles. You know, there are different types of triangles. You can talk of the isosceles triangle, equilateral triangle, the scaling, the right angle triangles. Of course, we see some of them here. Now let's go to the set S, and I'm using a different color here. The set S, a blue color, is a set of isosceles triangles. Isosceles triangles. So we have isosceles triangles here. So let us try to understand what we mean by an isosceles triangle. An isosceles triangle is a triangle that has got 2 sides and 2 angles equal. Example, if I do this, if I draw this triangle, and let me label the points of the triangle so that it will be very easy for us to identify the sides. Let me call this point A, and let me call this point B, and call that point C. Now the line from A to B is this line, and from here B to C is this line. That is the line BC. Then we have the line AC. Now what we're trying to say is that an isosceles triangle is a triangle that has got 2 sides equal, and if it has 2 sides equal, we also have 2 angles equal. Yeah, because the angle is directly proportional to the length that faces it. You see, so if I do this in geometry, we use these small lines just to show that these 2 lines are equal. So if I do this, what it means is that from A to C, the length from A to C is equal to the length from B to C. That is to say that if here is say 5 centimeters, then here will also be 5 centimeters. So that is an example of an isosceles triangle because it has got 2 sides equal. Now if it has 2 sides equal, it has 2 angles equal. So how do you find these 2 angles? First, you have to find out the lines they share in common. You should understand. Let me draw the lines that are equal with one color. So let's draw it again. I'm using a red ink for this. So let us assume that the red inks are equal, and I will use a blue ink here. So yeah, so that is our isosceles triangle, and then I'm going to show that this and that are equal. Now as I did earlier, let me label the parts. the triangle ABC here. Now, what do you see here? What is happening here? If you look at this angle is formed by two lines. Of course, an angle is formed when two lines meet. But the two lines meeting, we have one red line and one blue line. So this same blue line forms another angle here. So the angle here and the angle there share one common line. They have one common line. The only line that is different is the lines you see here. But fortunately, these lines are not even different because they are equal. We are saying that they are equal. So in reality, these two angles share the same lines. The angle at the point B has a blue line as one of its lines that form its angle. The angle at the point A has also a blue line. The angle at the point B has a red line, which is of the same length as the angle at A, which also has a red line of the same length. Because these two lines are, essentially the same, these two angles become the same. So if here is, say, 40 degrees, the angle here too is 40 degrees. And this is what we call isosceles triangle. It is a triangle that has got two sides equal and two angles equal. Now, where you place those two bars matter a lot. Where you place it matters a lot. So let me, for example, if I do this and I place them here, where you place them, you have to look at the tape. Where do they go? This line, if I bring it up here, they all meet here. So it is their bases that are equal. So that is to say that these two angles are equal. Now, if I put it somewhere here, this will be the tip because they come over here. So these two bases are the same. So isosceles triangles are triangles that has got two lengths or two sides and two angles equal. All right, let's get to the next triangle. The next set, the set Q. We are told that the set Q is a set of equilateral triangles. Equilateral triangles. All right, so let's look at the word here. Of course, iso also gives the idea of equal. I believe that you have heard of the word isotherm. I think in geography is some sort of imaginary line that connects areas of the same temperature. Iso and term, from thermometer. We have isotherm. So here we have isosceles triangle. So it has got two sides. But we can even take it further. We have another type of triangle we call equilateral. Lateral gives the idea of a line. Lateral, a line. So it's something like, and the prefix equi comes from equal. So equilateral is like equal lines. So an equilateral triangle is a triangle that has got all its three sides or all its three lines and all its three angles equal. So it's very easy to predict an equilateral triangle. All these sides are equal. So for an equilateral triangle, we put all these three bars here. You are not limited to putting only a bar, but what this means is that if you increase it to 2 bars, then you have to do the same. If here is 2 and here and there are just 1, it means that only here and there are equal. So there is an example of isosceles. But the moment I add 2, it means all are now equal. So there's an equilateral triangle. So I can decide to use 2 or 1 or 3. But why do I have to use 2 if I can use 1? Okay, so that is an example of equilateral triangle. And of course, one very interesting thing about equilateral triangle is that we know, or we can predict, at least we know, not that we can even predict, we know the interior angles of an equilateral triangle. Yeah, the sum of the interior angles of a triangle is 180 degrees. So if we are talking about an equilateral triangle that has got all 3 sides equal and all 3 angles equal, then it means that all the interior angles, each of the interior angles, is 60 degrees, because of course the sum of the interior angles of a triangle is 180. If the triangle has got 3 sides, we divide by 3, then we get each of the interior angles of a triangle. All right. So there is an example of an equilateral triangle. So that is the set Q. So we look at the set R here too. So let's go on to the set R. And what does the set R say? The set R also says that it's a set of right angle triangles. R is equal to right angle triangles. Right angled triangles. All right. So you can see that they are all triangles. So these are all examples of triangles. We have seen an isosceles triangle, we have seen equilateral triangle, and now we are talking about right angle triangle. Now, before we even look at right angle triangle, what do we mean when we say, a right angle? A right angle is a type of angle. It is any angle of measure 90 degrees. That is, if I do this, if I draw a vertical line and I draw a horizontal line, the angle here is 90. So we call this angle a right angle. Of course, here will also be 90 because there is a straight line, and the angle of a straight line is 180 degrees. Okay, so a right angle triangle, what do you think will be a right angle triangle? Can you guess it? A right angle triangle is a type of triangle that has got one of its angles to be 90 degrees, or of measure 90 degrees. So to draw a right angle triangle, I first have to make sure that one of the angles is 90. So that is 90. That is the symbol for 90 degrees. If you do this, it's 90 degrees, and you connect that because there is a vertical line and there is a horizontal line meeting, so it forms 90 degrees. So that is an example of a right angle triangle. Now, if here is 90, because the sum of the interior angles of a triangle is 180, if here is 90, what is left is 90. So here could be 30 and here could be 60, or you can have a lot of examples. If it is not 30, 60, what can you also think of? Here too can be it can be 40, and if here is 40, of course here will be 50, because this will be 40 plus 50, 90 plus 90. So you can be increasing and decreasing the angles, on and on. But there's something that will happen as you go on. You have to be very careful and take care of that. It's pretty much important here. What I want to tell you is that what is important about a right angle triangle is to make sure that one of the angles is 90. That's all. But as one of these two remaining angles increases or decreases, something happens along the way. For example, let us assume that this angle is, say, 40 degrees and that is 50 degrees. Now, if this angle decreases by 1, here will always be 90. For it to be a right angle triangle, here always has to be 90. But should this angle decrease by 1, this will increase by 1, because the sum of the interior angles always must be 180 degrees. So it will get to a point where this angle would decrease to 45 degrees, and when it does, then this angle here should also be 45 degrees. And when this happens, something very spectacular is happening here. We are now having two angles equal. If these two angles are equal, then of course these two sides must be equal. So we are kind of having a right angle triangle. All right, there is a right angle triangle. It is a right angle triangle because one of the angles here is 90 degrees here. We can see it here. That is the first scenario. And the second thing that we are witnessing here is that we are having two angles equal. And of course, if two angles are equal, that makes it isosceles. Of course, if two angles are equal, then definitely two sides too are equal. So that also makes it isosceles. So there is to tell us that we have one right angle triangle that is isosceles. So that means right angle triangle and isosceles triangle, they have an intersection. We cannot say that all right angle triangles are isosceles. No. Why? Because the only isosceles right angle triangle is when we have this 45-45. So how do we represent this on a Venn diagram? Let us see this. From the set, what do we see? Let us try to compare the two. So we see A, B, C, D here. We are going to start from the bottom here. So we have R and Q. Let us compare R and Q. R and Q. Right angle triangle and equilateral triangle. A right angle triangle is a triangle which has one of its angles 90. So the set R, we have a right angle triangle. Oh, there is a very bad straight line. Okay, I think that is cool. There is a right angle triangle, you see. And that is the set R. And when we scale up, we have the set Q, which is equilateral. That is a triangle that has got all three sides and three angles equal. Okay. Now, the question that we're asking here is that, is there any relation between them? Can we have a condition where a right angle triangle is also an equilateral triangle? Or can we have a condition where an equilateral triangle is a right angle triangle? All right, let's consider the first one. Can we have a condition where a right angle triangle is an equilateral triangle? No. Do you know why? Because for a right angle triangle, always one of the angles has to be 90. The moment one of the angles is 90, what is left for you to share for the two angles is the angle 90, because the sum of the interior angles is 180. So if here is 90, what is left? What is left is 90, and you cannot put 90 here and 90 there, because for this to be equilateral to, then all the angles have to be equal. So what we can say is that for a right angle triangle, that is the set R, and an equilateral triangle, that is the set, let me see, the right angle, yes, the set R, and equilateral, that is the set Q. These two are disjoint sets. There is no intersection between them. They can never meet, because you can never have a situation where a right angle triangle is an equilateral triangle. Because for, an angle to be equilateral, all of the angles have to be equal. And to do that, you have to share it 60, 60, 60. And for an angle to be a right angle triangle too, one of the angles must be 90. And if you have to, make sure that one of the angles is 90, you cannot, at the same time ensure that it is an equilateral triangle. If you want to satisfy these two conditions, then that means that you have to have something like 90, 90, 90. And that will make the total interior angles of a triangle, I think 270 degrees, and that is not true. So that is the first thing. So R and Q can never be together. They can never have an intersection. They are disjoint sets. So if you look at the options that we have here, try and spot R and Q. There is R and there is Q. Q is a triangle here and R is a circle here. And if you look at the A, there is no intersection between Q and R. So if we consider these two alone, A stands to be an answer. It is a potential answer. So if we look at the diagram B, is there any relation between Q and R? Of course, we have established that Q and R, the sets Q and R, are disjoint set. But where is it? There is the set Q here, a triangle, and the set R, a circle. But you can see that they are intersecting. There is an intersection between these two sets. So this makes the option B incorrect, because there is no way that a right angle triangle can be an equilateral triangle. At no instance that we would have an equilateral triangle being a right angle triangle, because for a triangle to be equilateral, all angles must be equal, and if all angles are equal, then it has to be shared equally. So we are going to have 60, 60, 60. There will be no 90 in it. For an angle to be right angle triangle, one of the angles has to be 90 degrees. And if one of the angles is 90 degrees, the remaining, if you share it, there is no way that none of them will be equal to 90, making it an equilateral triangle. So between Q and R, there is no connection. So that makes option B incorrect. Let me check option C. There is Q here and there is R here. So you can see that Q and R don't intersect. So this makes option C a potentially correct answer. So our options now lie in between A and C. Let me check D2. Q, oh my God, Q is found within R. So we are told that Q is a subset of R. That is to say that all equilateral triangles are right angles, and that is extremely incorrect. It doesn't make sense at all. All equilateral triangles are right angle triangles. And are you trying to tell me that? But equilateral triangle has all of its interior angles to be 60, 60, 60. And for a triangle to be considered a right angle triangle, one of the interior angles has to be 90. So because the Q is in the R, implying that equilateral triangle is a subset of a right angle triangle, it makes option B and D incorrect. So now we are left in between A and C. Which one is correct? All right, so let's go and consider the next statement. The next statement, we want to consider the Q and the R's. So what relation exists between isosceles and equilateral triangle? All right, we have talked about isosceles, we've talked about equilateral, but I want to talk about it again. So let me get here clean and talk about these two, and let us look at how these two connect with each other. Now I'm going to draw an isosceles triangle again. That is it. Okay, two sides are equal. Let me label it as ABC. And let me use red ink to draw an equilateral triangle. I'm going to label it ABC again. Okay, let me give this. All right, it's okay. So all the three sides are equal. Can you guess the relation between these two triangles? What qualifies a triangle for it to be called an equilateral or equilateral? What qualifies a triangle for it to be called equilateral? A triangle is qualified to be called equilateral if and only if all the three sides are equal, and of course all the three angles are also equal. What also qualifies a triangle to be isosceles? A triangle is isosceles if and only if two sides and two angles are equal. So the question is, what is the relation between isosceles and equilateral triangle? If you are thinking the way that I'm thinking, then let me tell you what I'm thinking here. I am thinking that an equilateral triangle, that is, all equilateral triangles are also isosceles. That is to say, if I use equilateral triangle, we use Q, right? So Q is a subset of S. You might think that, okay, come on, are you serious? Because for equilateral triangle, all the three sides are equal. Why are we saying that all equilateral triangles are isosceles? We are saying so because, the question is, what qualifies a triangle to be called isosceles? It is when two sides are equal. That is, two sides and two angles are equal, right? So now let us look at an equilateral triangle here. Let's take any two sides. Forget about the third side, because we want to check whether an equilateral triangle is also isosceles. Equilateral triangle has got three sides equal and three angles equal, but for it to be isosceles, we need just two sides. I'm just going to take two sides. The first thing that I want to do is I want to take the side AB and the side BC. Are they equal? That is AB and BC. You see the two bars on it? So they are equal. Let me take any other two sides. I'm taking AC and AB. Are they equal? I still see the two bars on it. They are equal. Let me take another side. So you can see that all equilateral triangles are isosceles. But let me look at it other way around. Are all isosceles triangles equilateral? What qualifies a triangle to be called an equilateral triangle? That triangle must have all three sides equal. And at a glance, you will agree with me that an isosceles triangle fails to be called equilateral, but an equilateral triangle qualifies to be called isosceles too. because if you take any of its two sides, it will still be equal. So Q is a subset of S, and if Q is a subset of S, then that means that Q is found within S. So equilateral triangle, that is the Q, should be found in the S. And if you look at the first one here, the Q is not in the S. They are just intersecting, trying to tell us that some equilateral triangles are isosceles. That is not true. All equilateral triangles, because all of them have three sides equal. So if you take any of the two sides, it will be equal. So the correct one is, if you look at this one, look at it here. The Q, the triangle, is found totally in the S. So this makes C the only correct option. So the correct answer is C, because all equilateral triangles are also isosceles, because if you take any two sides, they will always be equal. So that is how we solve this question, and thank you. We'll meet again.